How you all doing? It's great to be back up on stage here. Always, for me in particular, like seeing all this work that goes on in the community, extremely inspiring. I was just talking before, it's a really like an idea generation factory which is going on here, and it really kind of just inspires me in particular, and I'm sure a lot of you as well as part of that. Today, I'm really thrilled to share a lot of the exciting things that we've been working on at Seqera over the last few months. There's definitely a lot to cover there for sure. We'll just wait for the slides. Okay. Let me just check this here. I'll try again. Unplug it in and plug it out. Okay. Sorry about that. I'll just check that the mirror arena is right. Okay, displays. Yep. And let's just do mirror. Okay. Awesome. There's that there. Yeah, fantastic. So we should be able to go there. Okay, how's that? Take two. Yay, okay. So before I dive into all of the exciting things that we've been building, I wanted to take a step back and look a little bit at the bigger picture. So when we think about bioinformatics, we all know that it's moved on a lot from just being data processing. And we start to see that it's really incredibly powerful, not just as a tool, but it's also transforming the way that we approach science. It's not just something which is just on the end of your experiment now. With high throughput biology, we can even approach an experiment without even having a hypothesis. We can also use vast volumes of data to really create predictions and then be able to test those predictions at scale as well. And now I think in particular, due to a lot of the advances in software, we can go from not just making predictions, but being able to generate solutions there. And you start to see this in antibody and protein engineering. We'll see some examples of that from some folks later on. But overall, really, bioinformatics is starting to become the real engine which is driving scientific innovation, and software in particular. So I want to take a few moments now to look through a couple of examples where we're seeing this and some of the really impactful things that are happening with the science there as well. So kicking things off with Moderna. So with the mRNA technology, which is available today, you're able to now create vaccines that are really tailored to an individual's unique cancer profile. And bioinformatics is enabling that to happen. You can use the genomic data and the patient's readouts to identify the unique mutations and then really create a personalized vaccine against that. And a lot of this is also being driven from Nextflow as well. So the analysis of that sequencing data, the ability to identify the mutations, and not just that, but also the actual development process, the kind of design process that takes place in terms of creating mRNAs there is all possible now, things that we couldn't even dream of just a few short years ago. It's not only just been tackling in terms of cancer treatment, but also a lot of other diseases as well. Another big one, kind of critical application of bioinformatics we see here is in genomic surveillance. So organizations like the CDC, they use Nextflow now to track a lot of infectious diseases. And they're doing this in real time, being able to identify variants, monitoring how they spread. The analysis of this genetic data and this information is really happening now on unprecedented scale. You've got this concept of weather maps for tracking things like flu and other diseases as well. And the key thing here is that health agencies can then have real-time data on which they can act on, and they can make public health decisions based on that information as well. So really, again, this is an example of bioinformatics really enabling scientific discoveries that are having an impact on global health. If we think about other examples here, and we heard yesterday from our keynote speaker just how important it is as it relates to the challenge of CO2. This is an example of a company called Air Carbon, and they're using Nextflow and microbial sequencing to transform CO2 into really fascinating new biomaterials. These biomaterials are showing up in all sorts of places. They're being used by sort of very large consumer brands that you would all be very familiar with. And really by harnessing this bioinformatics as part of that, it's really able to actively engineer new materials as well. It's a really good example of sustainability in action. So these examples I've just discussed there, they really illustrate how software and bioinformatics is key to advancing this science. And it's really moving, I would say, from a supporting role to much more of one which is center stage. I recently had a lab mate from my master's thesis who came and stayed with me, and he had previously spent all his time at the bench. And he was telling me that how, just in the last few months now, he uses like AlphaFold almost like every day as part of his work. And that's kind of thing that is kind of crazy if you think about from even just a few years ago, and really a testament to how software is changing the lives of everyday scientists and really the way that they work as well. I don't think it's an exaggeration to say that software is now a foundational and a fundamental piece of scientific progress and going forward. And if it continues at this pace, it's kind of crazy to imagine what's going to be happening here. It's really that software is going to underpin all of our scientific discoveries. That's all super positive so far. And that sounds great. I'd love to live in that world, to be honest. But there's a bit of a catch. And the catch is that not all bioinformatics software is created by a Google subsidiary with 2,000 employees and billions in revenue. And so some of it's, there's a bit of nuance here in terms of really kind of what's happening here. Unlike software, which is developed by large tech companies, bioinformatics tools are really often developed like really without software quality standards. This is some quotes that are taken from a paper that came out like a week ago or 2 weeks ago. Some of you may have seen it on social media. It was in bioinformatics, but it just kind of looks at some of the sort of general issues with bioinformatics software. The focus is often on really being able to move fast, so fast functionality, and that's kind of a trade-off with maintainability. Without the kind of standards that are employed as part of that, the tools, they might work for yourself, they work on my computer, but really are they going to be scalable and be able to be used more widely? We also start to see here that if we think about the kind of results themselves that become very hard to, or the software itself becomes very hard to test and reuse and maintain. And that's something as well that's like thinking about how we can improve that and make that a lot easier for folks. And this was a really interesting one for me. And I think it kind of makes sense that in the academic setting, software is often developed by an individual or a very small group. And if you think about how software is developed in a large organization, it's often done in teams through much more kind of collaborative efforts. We've seen how in industry you can use the software engineering practices to improve quality dramatically. You get obviously things like sharing of resources, you get reviewing of code, you get following the best practices together, and really that kind of collaboration encourages the communication between teams, creating a culture where you're able to sort of interact in this way as well. So how do we, all in this room, as bioinformaticians, take an active role in improving the quality of the software that's out there? I believe it starts with embracing the best practices from software engineering, but doing it in a way which makes it easy for scientists to adopt those best practices in their own work. And these best practices obviously made a huge difference in different industries. I think that in science it's almost even more valuable given many of the constraints that we have in terms of the way that we work. Okay, further than this, how do we extend that to allow people without software backgrounds to be able to embrace this? This is not just software development of tools, this is actually applying software development to science. And that's a kind of really interesting, I guess, dynamic which is taking place. For many of the tools that you build, whether it's a core workflow pipeline, the user may be like a PhD student in your lab, but it could also be a developer on the other side of the world who's cloning the project and kind of taking it from there. How, if we're going to develop these bioinformatics tools, can we make it really essential to think about the broader scientific community that are going to be using those tools as well? Going to make them obviously intuitive, they've got to be robust, they've got to be portable, and really integrate well. And I know that many of you know these things, if you've ever heard them over many times, but I'm kind of sort of leading up to a lot of the things that have been developed inside of Nextflow as well. Last one here, and this is something which has come up a lot, but that point on collaboration. This kind of cuts through everything. It's not about the warm, fuzzy feeling you get from reviewing a pull request, although that's very good. It's really about working together, like through those code reviews, shared resources, open data, community-led initiatives, like so many of the things that we've seen here over the last day or so, to really create more robust and usable tools. If you've got 100 people, 1,000 people out there testing the software in all the different ways, the software gets better, and the better software creates better science. Open source projects like Nextflow and NFCore are real, like just have shown how powerful that collective effort can be. On to Seqera, like our mission is simple, and it's really all about this. We aim to advance science for everyone through software. Believe that when people have access to those tools that support quality software standards, then they're empowered to push the boundaries more. They're empowered to do better science. We want to remove the barriers, streamline the workflows, make it easier for every scientist, from students, to researchers, to really achieve more with that. And these principles, as I was saying before, they really date back far beyond and even before Seqera was created. So I'm often asked, like, what has made, I guess, Nextflow successful in the scientific community? And for me, I'm just going to hopefully get this on here. I'm kind of thinking about it as like four core things that I talk about. Firstly, code. And we want to create something which is really amazing for scientists to use and to develop in. So it should be readable, should be modular, designed to be easy to understand, to extend in this way. Obviously, containers themselves as well have been a huge part of this, and containers are something we continue to develop and push the boundaries on. They make the pipelines portable, reproducible, and new tools like Wave, I think, are making that even easier. We're all riding a wave of what I like to call like elastic execution in the cloud, where these workflows, they stream and can scale seamlessly across different areas, across different providers, regions. And then finally onto the collaboration, whether you're using GitHub or Slack or just really events like this. It's really like a community that is as committed to open science and to supporting that research as anything else as well. Okay, and as I said before, these four concepts are really embodied in Nextflow. I think there was a lot of kind of foresight from Paolo very early on to be able to like understand these concepts and build them in. And so as we enter the 11th year of Nextflow, I think we start to see that this is becoming more than just a little niche thing that you're doing. There's a much more kind of broad adoption here. So Nextflow is now the most cited workflow manager, and its growth is accelerating. And that kind of acceleration is super exciting. It's not just in academia as well. Like one of the most remarkable aspects of Nextflow has been its broad adoption across different sectors. And we're starting to see that broad adoption even going outside of life sciences now. We also see like solo researchers using Nextflow to streamline their analysis. So really kind of often managing very, from a single researcher with a single project all the way up to like biopharma who are running things at scale, supporting that thing from R&D to clinical, even kind of commercial applications where the sequencing or the analysis of the data is part of essentially a health product. We saw some great examples yesterday in terms of using these pipelines as medical devices. And I think Nextflow's flexibility here, providing it's like a single individual or whether it was enterprises running all these workflows, it really makes an improvement in terms of making that software quality much easier. Okay, I'm going to jump forward now and have a little look now at how we can support like the different phases of this. So a lot of the focus we've talked about has been on workflow management, on pipelines themselves. But bioinformatics is not just about running a single pipeline. It's really about supporting every phase of that. We're from research, development, clinical, and really we think that Seqera is the best place to run Nextflow in that regard. We've been building this infrastructure where you can connect your resources, seamlessly transition from building to deploying to scaling your science, and as well create this robust like ecosystem for the scientific data analysis lifecycle. It's really one that's all optimized and one that is trying to support this high-quality software standards with the flexibility and the kind of scalability across this. Okay, and this kind of brings us on to some of the pillars that the way that we like to think about almost how we structure a lot of the work that we do. If we think about like how each of those pillars kind of supports it here, so just go through here, we obviously have build and the open source tools that we have in terms of Nextflow, MultiQC, Wave. These are foundational tools which people can build on top of. They can integrate, they can use how they see best. We also strongly believe in free and easy access to community resources. So things like containers and ready-to-use pipelines, which help scientists really find the right tool that they need quickly. And finally, we've been creating this scientific infrastructure needed to run everything at scale. So Seqera platform's core to that, connecting your data, your code, your compute, and your analysis in this collaborative environment. I'm going to start with Seqera containers, and I think this really exemplifies this idea of creating community resources. The origins of Seqera containers date back a little bit to the introduction of Wave, and if you were here a year ago, we had the general availability release of Wave, this concept of using just-in-time containers, and really Seqera containers is like the productized version of that for folks to use. So we launched this in Boston earlier this year. And the idea is it's a completely free service where you can build containers on demand using Conda, BioConda, Python packages to be able to do that. It's stored securely in AWS as well as then served via Cloudflare. There's now over 3 million containers which have been served every month, which is just amazing given it's really just kicked off. I mean, it's not just providing the flexibility there to create those containers. I think it's a great example, similar to Nextflow, where you build the reproducibility in, and by building the reproducibility in, it reduces all of the friction associated. It basically means that like good software practices, they're not at odds with ease of development. In fact, they make the development easy in itself. I know many of you have been using this for a while. Paolo's going to give a talk after lunch. He's going to talk a bit more about the evolution of Wave and Seqera containers as well. Okay, but for now, let's dive into the new stuff and the exciting features that we're going to be unveiling at Barcelona Summit. And I'm going to kick off with pipelines in particular. Okay, so pipelines are really like the backbone of scalable bioinformatics. Probably the main reason why many of you're here today. At Seqera, we're really committed to making the pipeline experience more powerful, flexible, and also accessible for the various different users who need to interact with pipelines. In the latest release of Seqera, we have the improved pipelines launch form. This idea is to kind of streamline the process of launching pipelines. We've also integrated better with Data Explorer, so you can find data, whether that's when you're launching a pipeline, or if you need to find the data in the context of a task, for example. And finally, we continue to push a lot of the work around the performance optimization of these pipelines as well. So all of these improvements really come together to make Seqera the best place to run Nextflow. But enough talk, let's jump into a demo now, and I'll kick things off here with starting with Seqera pipelines. Sorry, my window's a little bit smaller than I was predicting here, but I will try and expand here. Okay, so you should all be able to see that well. So I'm going to start off here in terms of launching a pipeline. So I'm going to find a pipeline that I want. I'm just going to use an example of one of the more recently released ones that we have. So this is like a single-cell RNA-seq pipeline here. When I click into this, you'll see there's a variety of providers here. What this is able to do is add this pipeline to a specific organization. So I'm just going to add it to Seqera. Going to add it to the showcase where we're going to do this demo. And then I can also choose a computer environment that's required here. So by adding this pipeline in, this is more than just the repository. So you typically think of a Nextflow pipeline as just a repository. Here is kind of including all of the specific configuration to be able to run that. You can put parameters, and almost like a version of the pipeline in itself here. So going through to launch this pipeline now, we have the new launch form, which includes in itself ability to see sort of different run parameters. So if you were looking for particular input data, you can browse data sets. You can browse various different data that you have associated with this workspace. So this is like public data across multiple different clouds. It allows you to browse into that to find the data that's relevant for you. The launch form now has also got very nice, for example, drop-down features that you can add in this. And this is taken from the NF Core schema, so that it's able to render this in a way you just really can drop this in and run this. So I'm going to kick this off here, and a little bit like cooking, I've got one that I've prepared earlier, because you don't want to wait around for a few seconds and watch that. Here's the same pipeline I just launched earlier this morning. So going through to some of the new things that we've been adding in, I think particular, when you've got a pipeline with multiple different steps, not everything works all the time, unfortunately. If you want to be able to dive into that and kind of see exactly what's happening, I'm going to say take the FastQC, so the first process here, or first task that's here. I can dive in and see exactly what got ran. But also I can now jump into the Data Explorer here. So this is the task work directory, and I'm able to jump in and view, for example, what went on here. I can just open this in a new tab, for example, the FastQC report. And again, this is like on an S3 bucket. It allows me to kind of provide that instant access into that. Super, super useful for being able to debug as well. And then in terms of once the pipeline's executed here, I can sort of close all this. Just going to go back to the start here. Once these pipelines are run, there's of course a lot of the optimization that we've been running here. So I can take any pipeline that's been executed, can optimize it for CPU, memory, etc., and they will request the right amount of resources for that using all of the fantastic kind of retry functionality that exists there. Okay, so how does all of that kind of work in practice, and what does it sort of look like there? Key metric for many organizations who are running at scale is really about the costs, and particularly the cost per sample if you're running high throughput work. See some typical RNA-seq analysis. So this is running RNA-seq from NF Core, looking at our $40 per sample and some legacy providers there. We've been able to get, and this is just kind of off the bat, you can get samples at $6 per sample, kind of run on your own compute on Seqera platform there. And once we bake in some of the work that Paul is going to be talking about later on with the performance optimization using Fusion, we can see that we get down to $3 a sample there. And it's not just us who says this. If we look at some of the examples of customers there, so we've got folks like Strand Life Sciences, really achieved a 66% reduction in their costs there. Similar with Arcus Biosciences, as well as Sage there as well, who really improved a lot of the not just the compute time, but the human time, which is often much more expensive, as I'm sure you're all aware. There's kind of real world examples where we can see like how Seqera is like not only lowering the costs, but really enhancing the efficiency there as well. Okay, so that was touching on pipelines. Let's jump into analysis, and this is obviously the place that we really start to get the insights that are coming from the data there as well. You remember that like from exactly a year ago, we had the preview launch of Data Studios that happened in Barcelona. And this is a tool to kind of interact with data, to bring together your data and your compute in an environment that you're typically comfortable with, that you're used to. So for example, Data Studio supports your IDEs that you're familiar with, so Jupyter, RStudio, VS Code, and then importantly deploys them in your environment. So in the same place that you would run the pipelines, for example. And again, we're trying to embrace some of the lessons of Nextflow, the kind of idea of making it easy to adopt these quality software practices in having an interactive environment there. A lot of this is obviously enabled by containers. So today we're excited to announce a ton of new features as it relates to this. And first off, and this is like one of the most requested features that's been around, which is around customized environments. So here you can now specify a Conda environment, a custom Conda environment, and behind the scenes, Wave will augment the studio, so we'll essentially build the Conda environment into that container, and it will kind of serve it to you there. There's also the possibility to have a custom container. So if you have your own custom container with proprietary tools or specific things that need to be run there, that's also possible as well. seen a lot of demand for GPUs, as I'm sure you're all aware of. This kind of ability now to be able to use GPUs with a single toggle. And I think more importantly, it's able to really make all the drivers accessible. And there's obviously a fair bit of configuration which takes place to making sure that, for example, all the NVIDIA software is deployed there, makes it super simple to run AlphaFold and in these areas, as well as checkpointing, which is this ability to go back in time and to go take any moment in time from your studio environment and checkpoint it, and then obviously fork and copy from there. So let's take this for a spin then. I'm going to go now and have a look here at the studio's environment. So similar to before, I've got one that I've got running here. To add a studio, if you're a user, if you want to come in and try this out, you can add a studio here. Again, it runs in the same computer environments that you have set up there. Really, really cool feature, and this is something which I think continues to really get a lot of sort of good impressions, is around the ability to mount this data. So what this does is it mounts data from public buckets or private buckets or anything you've got inside of the studio, and then you can treat it like a file, like a local file. So in my case here, I'm just going to go through, and you can see that these markers here, they're basically saying don't mount data from other regions, or check exactly kind of where it is. You don't want to be spending a lot of money moving things around from different regions, so you can create a computer environment in the right area. I'm going to mount this data into this environment here. I've got a config. I can choose which studio I wish to launch. So whether this is like a custom one, in this case, I'm just going to choose a Jupyter environment here. And the new thing that we have today as well is this ability now to install Conda packages. So I've just got a Conda environment that I've got here. It's got SAM tools, it's got PyGenome tracks, it's got MultiQC. Can copy all of that here back into that environment, paste it inside, and then from there, that's going to build that Conda environment into that studio and get built there. It's going to take a couple of seconds to bake up before we wait around for that. I'm just going to show you one that exists before. So here is the exact same thing I've just done earlier. You can see that now I'm in this Jupyter environment, and I have this ability to pull up a terminal as you would normally. I'll just zoom that in for a little bit for you. Importantly, as I mentioned, the data is all mounted there. So you can see they've got iGenomes mounted. I can perform a task as I would. I'm just going to copy something from here. So I've got SAM tools, and I'm just going to do a view on chromosome 21 of data, which is in a public bucket, but I can treat it like it's just local to me here. Hopefully you can all see that. And you can see that it's just basically treating it like that. So that's a That's all really enabled by a lot of the fusion technology that we've been building in, but again, it kind of makes it seamless in this way to work across cloud and across different regions as well. Okay, let me just go back here into Seqera. I want to show you a few more features around that environments stuff, because there is a lot of cool things under the hood that are happening there. So if I just go zoom out a little bit here, and then if I show you to Data Studio, so if we think about the one that I just launched, I can view that, and I can also see, for example, the summary of the build. So what was kind of happening behind the scenes. So you can see that Wave built this. We can see the Conda file that got used, but also the Conda lock file. And that's like super important if you want to fully reproduce exactly what's happening there as well. We've also got security scanning into Wave now, so it automates a lot of those processes. As a user of a studio as well, you've got this checkpointing feature. So I could create a checkpoint of this in time and then go back to it at any moment, have a colleague come in, jump it. I can set up environments for them and run all of that as well. And finally, we've added a new dashboard here. So this allows you to get an overall view of all the pipelines that are running, as well as all of the data studios that are running. So this is across organizations and workspaces as well. Very handy if you like to leave things running occasionally and you get a little bit distracted, but it's always good to be able to come back and see what's happening, especially if you're the one that pays the bill in particular. Okay, so jumping on now to what's coming up next with data studios. So we were trying to increase the support for different clouds, and this is really kind of building towards general availability of data studios, which is coming out later this year. And improving the launch time, so we're able to speed up the time that it takes to get really that down to just a few seconds. And then one thing in particular I've been most excited about for Data Studio since the beginning is integration with Git. And I think about Nextflow and how Git just enabled all of this collaboration, all of these people working, all of you building pipelines in NF Core. My idea for this, it'd be fantastic to have a similar, an ecosystem of people who are building studios in the same way that we see pipelines. So being able to define a studio with Git, I think will really open it up. I'm also optimistic that making this super simple, we can have a whole new set of scientists who are using this technology, again, who can see the joys of experiencing building software with these quality standards and just how much better it makes the science as well. Okay, so speaking of kind of like getting a whole new set of users and developers in, let's speak about development and Nextflow development specifically. So if we look around the best developer experiences that exist today, you can think about projects like Python or Java, and they've got like a plethora of different options that you can use, really to make the coding more fun, more effective, more efficient, and all of those tools really help that experience. When we think about bridging the gap between scientists and developers, we really want Nextflow to let users to have that same experience and like have a way for them to have the same kind of tooling that exists out there. And really today is a really key step in making that a reality. So today we're releasing the Nextflow language server, which is part of the Nextflow VS Code extension. It has a whole bunch of really smart features in it, so error and warning messages, code completion, navigation. You've got automatic formatting, support like, for example, like hover hints, etc. And all of this is just really going to help the experience to allow developers to build Nextflow more successfully in a way which kind of really makes sense. So Ben and Paolo are going to go really dive into the details of this after lunch. But I guess kind of like overall, if you're interested in trying this out, it's available already in the extension. So if you're using that, it should automatically update for you. It's also available inside of VS Code and Data Studios. So you can try that out here. It's a little example of how you can run VS Code, pull in an Nextflow pipeline there, and you get all of the kind of the syntax highlighting inside that studio as well. Okay. Almost lunchtime, we make it. Let's face it, writing code though, I mean, like it's a little bit out of fashion these days. And if we look at the trends across developers, like AI code generation is really only heading in one direction, according to ChatGPT, anyway. So how does this brave new world of code development fit with bioinformatics and science? Is what we're doing in terms of bioinformatics and science, is it just like other software engineering? Is it going to be able to go down this path, or is there something different in what we do? I think that there's a bunch of nuances here about bioinformatics. We've got huge complex data sets, a variety of different tools, heterogeneous resource requirements, a lot of reproducibility issues. I think about how can what we see that's been developed by some of the large model providers really fit with what we're trying to do. If you think about a typical web application, you can generate code, click a button. Does it look right? Yeah, it looks right. If you think about a bioinformatics pipeline, though, it may take hours to run. You've got various different data sets. How are you going to bring those in? Different hardware, undocumented tools. How can we leverage maybe what we've learned from Nextflow in terms of containers and cloud and collaboration to not just generate code, because code generation is essentially free now, but how can we generate code that runs and code that solves scientific challenges? I don't have all the answers to this, unfortunately, but I would like to invite someone onto stage who's thought about this a little bit more. So please welcome Sasha, the founder of TinyBio, now part of Seqera, who's going to introduce the world to Seqera AI.
Thank you, guys. Thank you, Evan. So we're going to do a live demo. All right. So Seqera AI, really it's quite opinionated. So I'll start off with a very basic question. Hi, my PI has asked me for an RNA-seq pipeline. Okay, so the reason why we chose chat for rolling out Seqera AI is because it is a format that a lot of novices are going to use, and it's still useful for experts. So as Evan was saying before, there's going to be a lot of new folks that are getting onboarded. Now, the main difference between us and everybody else is that we're not just going to spit out random code. We want you to use the tools that are already out there, right? We don't want another random RNA-seq pipeline out there. We want to use pipelines that are tested and are community verified, right? So a lot of what we do is really, really rooted in Nextflow and really a lot of the Nextflow community guidelines. So that way, when somebody does ask for an RNA-seq pipeline, well, we'll give them one that works.
That's pretty cool, but like, not everyone uses Nextflow, and there's a bunch of other stuff out there in bioinformatics which isn't Nextflow.
Yeah.
What can we do about that?
Yeah, so there are a lot of people that are Nextflow curious. So for those people, a lot of folks have great pipelines that do work, but let's say that they want to see if they will work in Nextflow. So for this instance here, what we'll do here is we'll actually paste in a pretty long variant calling pipeline. And we'll say, hey, Seqera AI, can you make this pipeline Nextflow? Also, let's juice it up a little bit since this is a live demo. Please do a good job. My boss is watching. Okay, so let's see what we get here. All right, cool. So it acknowledges the importance of the situation, and then it starts generating the code. So here, again, it's going to be very, very different in terms of what we get from a typical AI generation. But we're going to be very, very opinionated. So for one of the things that you'll notice is that our syntax is actually DSL2. These are one of the things that we've done with the frontier models to really push them so that way when you're pasting the stuff into your IDE, you don't just get old Nextflow code that was part of the foundational training. You get DSL2 code that's new, that's up to date, and that will actually work. The other So the other bit of it is that you'll see here is that we pasted in a pipeline that was fairly monolithic, but what we're getting back is modular, right? Again, what I want to stress is that a lot of the folks that are going to be coming in, especially through a chat interface, are not going to know all the best practices. So we want to reinforce them from the very start. But this is the Nextflow conference, so there's a lot of people that are not new to the Nextflow development, so we wanted to have something for them as well. So in here, let's do, can you please write an NF test for the merge BCF process. And so here, again, we want to support good software practices. Now, what that means is actually doing it, right? It means that we want to make things like testing very simple for novices and for experts alike. So that way, we're going to support the community and the latest standards of what it produces. So in here, we see there's our NF test.
Cool. So this is like so far. So far, this is still just like code generation. Though.
Yeah.
This is just text to this
Yeah.
To this box. How do we make sure it runs? How can we do that?
Yeah. So that is the golden question in bioinformatics. Obviously, will it run? Right. So in this aspect, we're going to switch over to another window here where I've generated an RNA-seq workflow. But within each individual process, you guys might notice a script testing module that allows you to test it in an AI sandbox. And we have this button here called Start Test. Should we push the button, Evan? You guys want to push the button?
Should we push the button?
Yeah. Okay. All right, let's push the button. All right, but as with any workflow, it's not just going to be one process, it's going to be several. So let's start the test for the other ones as well. All right, cool. So I'm going to go back to FastQC and talk you guys through exactly what's happening. So when we push the button, what happens is that the AI spins up a micro VM that has Nextflow and Wave already installed on it. Then what it does is that it uses Wave to define an environment for the process to run in. Then it goes to NF core test data sets to find the right sample for the process. And then it writes it to a file. Now, when I say write to a file, I don't mean like just spit out tokens. I mean write it to a file. And so I will show the file that this has written here, in here. And so we see here, it took that simple process and added things around it in order to make it test, in order to see if it will actually run. And it adds the conda fastqc here. Now, this is ready to run. And the model is actually inputting our favorite words, Nextflow run. And what it's doing right now is that it is actually executing this code and seeing if it will actually run. So if we scroll down further, awesome.
Amazing.
It ran.
So a lot of people are going to be looking at this and say, hey, that's just like a single process there. And our pipelines are pretty modular now. You've got a lot of structure that's involved in them. How do I get this out of here and into somewhere that I can try this locally or use this in a way that's kind of more valuable?
Yeah, so we have this other tab called the local testing guide, which what it does for you here is that it generates a set of instructions for how to do this within your own environment. But the most important part in this aspect is that it's leveraging the NF core test datasets repository in order to find the samples that will actually be useful for this specific process. Now, within those samples, and why we're shouting out NF core test datasets, is that those samples are very small. So you can get feedback quickly to see, hey, will this process work? Will this workflow work? Right? But as Evan mentioned, in a workflow, there's usually several processes. So let's check out how we did with the others. Okay? So here we have Thermomatic. Okay? Everything worked here. Star. Okay. Everything worked here. Feature scripts. Feature scripts. Oh my God. There's an error during the live demo. Oh no, look guys, command run failed. All right, let's go see what happens here. Okay, so we have a typical error messaging here. But Seqera AI sees the message. And it says, I see the error, we need to add the -p flag to handle paired end reads. Let me modify the script. So then it goes to feature counts, and it actually modifies the script. And then it runs it, and now it works. So for us, this flow, I think especially for novices that might not know about something like a -p flag for paired reads, is going to be fantastic. But on that note, I did want to talk about our self-correct features for, larger processes. The system is set up to be very resilient. So it will take about 10 tries in order to fix itself. So you can give it some very gnarly processes, you can give it some very gnarly Nextflow logs, and it will do its best to kind of find the right sample and try to reproduce and fix your issue. So in a word, This is Seqera AI, and it's available at seqera.io/askai today. And so the main reasons why we think that people in this audience, it's going to be very useful for them, is that we can convert any bash/language script into Nextflow. We have AI error debugging and code testing, and we're rooting in Nextflow and a lot of the Nextflow best practices. But as Evan was saying earlier, bioinformatics is a team sport. And today, I wanted to show a Sara AI API sneak peek. Now, what this means is that we want to be able to offer a lot of what we do as an API to everyone in this community. And we've actually already done this for one of our favorite products, multi-QC. So now, for this portion of the demo, I'm going to show you guys a multi-QC report. But can anyone spot something different? There's a Sara AI summary here that gives you an easy-to-interpret AI summary of exactly what happened during this report. Now, a lot of this work has been made possible by Phil and his team, and it's a great reason to come back after lunch to see what else we can do here. So, as with everything I showed you guys here, especially with the Sara AI API, we want your feedback, right? And so if you want to build on top of what we're working on, please, please, please leave feedback on Seqera.io/feedback. We promise we read it, and we promise we'll get back to you and put something great out there. Thank you, guys.
Awesome. Thanks, Sasha. 2 minutes. Sorry, I think like what excites me, we think about code generation and stuff, but the ability to go from not just like code generation, but actual analysis of data, I think it just opens up a huge range of possibilities here, particularly if you believe in an agentic future of AI as well. So summing things up, we've seen a lot of new stuff here today. I'm not going to go through all of this. There's going to be specific talks on many of these things that are coming up over the next 2 days, but feel free to reach out to any of us, the Seqera folks around, to talk about any of this. Finishing up, though, on the kind of why, and why all of this is important. If we really think back and look at the work that's happening and what Nextflow and NFCore and really the community is enabling, we've got so many fantastic examples to do this, and it's really a reason, for me anyway, that you can wake up every morning and really feel fulfilled in your work to do this. Examples of Vertex with the transformative therapies around sickle cell. Genomics England, who are working with sequencing every newborn to really act in terms of preventative care, as well as folks like at Moderna with the personalized medicine that's available there. And all of this work and all of the things that you're doing are really contributing to this. Sometimes we feel further away from it, and sometimes we feel closer to it, but it all really contributes, and it's not always public, but you should really know that it's really making a big impact there. So, wrapping things up, next up from Seqera, we're going to have Phil, who's going to be joining us and talking about multi-QC. Paolo's going to talk about what's new in Nextflow. We've got an update on the NFCore ecosystem as well from Phil. As well as tomorrow, we've got Rob Syme talking about some end-to-end practical examples of what you can do, and as well finish up with Geraldine on navigating the career path. We've got our Ask the Human at the booth. Don't ask the booth, it will be a very painful conversation. That's up there. Thank you all so much for your time. Apologies for the delay, but enjoy it. Talk to you all soon. Thank you so much.